So let us start with the first one. Let I is equal to integral sec to the power of 4x tan x dx. Okay. Now here what you do is, you know that the derivative of tan x is sec square x, right?
Yes, sir.
So you break this up, the sec to the power of 4, you break this up as sec square x into sec square x and into tan x.
Good afternoon, sir.
Good afternoon. Dx. Okay. And what you do now here is you change one sec square to tan square. You know that sec square theta is equal to 1 plus tan square theta. So you
Yes, sir.
change one of the sec square to tan square. Only one. Okay. Tan x sec square x dx. Now in this what you do is, let t is equal to tan x. Okay. That means what is dt dx? Dt dx is sec square x. That means dt is sec square x dx. So now what happens? This becomes your dt, right? And tan we have already assumed to be t. These two are t. So this integral becomes what? 1 plus t square into t dt, right? This is what it becomes. So now what happens? How will I evaluate this integral? You can write this as t plus t cube dt, which is integral of t dt plus integral t cube dt, which is half t square plus 1/4 t to the power of 4 plus c. Now you can put back the value of t. So half tan square x plus 1/4 tan to the power of 4x plus c. Okay, so this is how you evaluate the first integral. Let us now see the second one. All these are your ISC problems. Second one is integral x cube by x square plus 1 whole cube. This is the question. X cube divided by x square plus 1 whole cube dx. Okay. Yes. This is your question. So how will you evaluate this integral? What you do here is you write, you know that the derivative of 1 plus x square or simply x square also is 2x, right? That means you
Yes, sir.
break this x cube as x into x square. Okay, x into x square. And the denominator you have x square plus 1 whole cube dx. Now what you do is you put 1 plus x square is equal to t. That means what do you get? dt dx is equal to 2x. That means what do you get? dt is equal to 2x dx. That means you get x dx is equal to half dt, right? Now why have I taken out x dx? See, you have an x here and you have a dx here. These two combine to give you a half dt. Now you understood why I put 1 plus x square is equal to t. Because I knew that the derivative of 1 plus x square is
Yes, sir.
2x. So I have an x here. That is why I put 1 plus x square is equal to t. So now what I'll do here is I'll put the values and change everything to t. So therefore I becomes integral x square we have taken. If 1 plus x square is t, then what is x square? X square is t minus 1, right? So instead of x square in the numerator, I put t minus 1.
Yes,
And x dx is dt. So I write dt divided by, and x square plus 1, I have taken it as t. So t cube. So now this is can be evaluated very easily. You separate, you get t by t cube dt minus integral dt by t cube. So this t and this cancels. So you're getting integral dt by t square minus integral dt by t cube. Now apply the formula. This is integral t to the power of minus 2 dt minus integral t to the power of minus 3 dt. Apply that x to the power of n formula. You have t to the power of minus 2 plus 1 by minus 2 plus 1 minus t to the power of minus 3 plus 1 by minus 3 plus 1. Okay, so this becomes minus 1 by t, and this becomes plus 1 by 2t square. Okay, plus c. And now we put back the value of t. T we had taken as 1 plus x square. So this becomes plus 1 by twice 1 plus x square whole square plus constant. So this is your required integration. Okay, let us see the third one. All these are your ISC problems. Next one is integral cos x minus sin x divided by cos x plus sin x dx. Okay, so how will you evaluate this integral? If you see, if you differentiate the denominator, will you get the numerator? Just check. Just check if you differentiate the denominator, will you get the numerator? Yes, we'll get. See,
Yes, sir. Yes, sir.
let t is equal to
Yes,
cos
sir.
x
We will get it.
plus sin x. So in fact, I'll just say that if you see, this is of what form? Integral f dash x by fx dx, right? So in fact, directly you can write this as log of fx plus c. In fact, directly you can write this as answer is log cos x plus sin x. But since 3-4 marks will be allotted, we'll show it. Okay. So let t is equal to cos x plus sin x. Therefore, dt dx is cos x ddx of cos x is minus sin x, and ddx of sin x is cos x. So therefore, what is dt? Dt is cos x minus sin x dx. So see, we are getting the numerator. This entire thing, cos x minus sin x dx, this entire thing is your dt. So therefore, what does I become? I becomes integral dt by t. So this becomes log t plus c. Now you put the value of t, log of cos x plus sin x. Okay. So the next one and the last one from here, you have integral sin x by a plus b cos x. A plus b cos x dx. Now how do you evaluate this integral? Again, if you see, if you differentiate, see that a and b are constants, right? A and b here are constants. So if you differentiate the denominator, you will get the numerator, but with a and b. Okay. So as long as the constants are there, I am not worried. So that is why I'll put t is equal to a plus b cos x. So what will I get here? Dt dx is equal to minus b sin x, right? So therefore what is sin x dx? See, in the numerator you have sin x dx, right? This one. So what is sin x dx here? Sin x
Yes, sir.
dx is minus dt by b. Okay, so now you change everything to t. A and b you don't need to worry about because a and b are constants. Therefore, I is equal to integral, instead of sin x dx you put minus dt by b divided by t. Okay, now what will happen here? You get, you take minus out of the integration and you take minus 1 by b out of the integration, in fact. So you're left with only dt by t. So you get minus 1 by b log t plus c. So you get minus 1 by b log, and what is t? T is a plus b cos x plus c. So this is your answer. Okay, so these were four important integrals. Let us now
Yes,
move
sir.
on to some further problems on integral. Now there are some standard integrals that you must remember, and you must also remember how to derive these formulas. Okay, some standard integrals you must remember, and you must also know how to derive these formulas. The first integral here is, remember, you have to remember both the formula as well as the derivation. So first formula here is that integral tan x dx is log sec x plus c. Okay, and if you have inside tan, if you have a linear polynomial, like say um, tan ax plus b, if the power is 1 inside tan, then we'll write this as log sec ax plus b divided by the derivative of ax plus b, which is a plus c. Okay, so remember both ways. Whether it is
Yes, sir.
tan x, you have to remember tan x is equal to log sec x. Also, you have to remember that log integral tan ax plus b is log sec ax plus b divided by the derivative of ax plus b. Now, how do you prove this formula? I assume let I is equal to integral tan x dx. Okay, so in this, what you do here is you first change tan to sin by cos. Okay, now you know that the derivative of cos is sine. So put t is equal to cos x.
Yes, sir.
That means you get dt dx is equal to minus sin x dx. That means what is sin x dx? This one, this part, sin x dx. Sin x dx is minus dt. So therefore, what does I become in terms of t? I becomes integral. Instead of sin x dx, you write minus dt, and the denominator you have a t. So it simply becomes minus dt by t. You take minus sign outside the integration, you get minus dt by
Yes,
t.
sir.
So you get minus log t plus c. Now what is, put the back the value of t? T is cos x. Now you
Yes, sir.
know that
Cos x.
we are getting minus cos x, but this can also be written as log cos x to the power of minus 1. If I remove the minus sign from the beginning, it will come to the new, it will come to the power of the log, right? If you remember the properties of log,
Yes, sir. Yes.
so this will become log 1 by cos x. That means this will become log sec x, and you give a plus c here all throughout. Log sec x plus c. That's it. That is how you prove. Okay, let us look at the second one. The second one you can
Okay,
prove
sir.
similarly. I'm leaving it to you as an exercise. Exactly similarly, you can prove the second one. Okay. Uh, the second one here is formula. Okay, formula. The next formula here is log. Sorry, integration of cot x dx is log sin x plus c. This you prove exactly in a similar manner. You write cot x as cos x by sin x, and then put t is equal to sine x, and then proceed exactly similarly. So therefore, if you
Okay, sir.
have integral cot ax plus b dx, then you can write this as log sine ax plus b divided by the derivative of ax plus b, which is a plus constant of integration. Okay, so I'm not proving this formula. Next formula that you need to remember is
Okay, sir.
next formula that you need to remember here is integral of cosec x. Okay, integral cosec x. Now this integral has two forms. First form is log cosec x minus cot x plus c, and it can also be shown that integral cosec x dx is also equal to log tan x by 2. Okay, I'll show you both. Now before showing you both,
Yes, sir.
what you must remember is that if you have integral cosec ax plus b, then what will you do? You will write this as log cosec ax plus b minus cot ax plus b whole divided by the derivative of ax plus b. And what is the derivative of ax plus b? It is a. Okay. Also, if you want to write in terms of
Okay,
tan,
sir.
it will be log tan ax plus b divided by 2 whole divided by the derivative of ax plus b, which is a plus c plus c. Okay, this is just for your information. Basically, what you'll have to remember is these two. So, coming to the proof, I'll show you the first one and then the second one also. This is for the first one. Let I is equal to, I'm writing here first part. Let I is equal to integral cosec x dx. Now what you do is, this is actually cosec x divided by 1 dx, right? So what you do here is that you multiply the numerator and denominator by cosec minus cot. Why cosec minus cot? We'll see later. So cosec x, you multiply the numerator and denominator by cosec x minus cot x.
Sir,
Hmm.
sir, can you explain this concept, cosec x minus cot x? Uh,
You are
how you will
this.
approach that one?
See, this is cosec x, right? Cosec x, you can write cosec x divided by 1.
Yes, sir.
You, and now this is the your numerator, this is your denominator. Cosec x is your numerator, 1 is your denominator. So if you multiply the numerator by cosec
Oh,
x minus cot
yes, sir.
x,
Yes.
and multiplying the
Okay, sir.
denominator also by cosec x minus cot x. That is what I have done.
Okay, sir. Understood. I got.
Now, why have I done this? We'll see after two steps. Why have I multiplied? Okay. So what you do here is you first multiply the numerator, you get cosec square x minus cosec x cot x divided by cosec x minus cot x. Okay. Now see, if you differentiate the denominator, will you get the numerator? Just check. If you remember the derivative of cosec x and cot x, try to differentiate the denominator. See whether you get the numerator. Actually, we will get. Let t is equal to
Yes, sir. We are getting. Yes, sir. We are getting.
cosec x minus cot x. Therefore, dt
We'll get.
dx is ddx of cosec x is what? Minus cosec cot, right?
Yes, sir.
And what is ddx of cot x? ddx of cot x is minus cosec square x.
I think cosec x.
So what are you getting here? you're getting cosec square x minus cosec x cot x, right? So are you getting the numerator here?
Yes, sir.
Yes,
Yes,
we are
Yes,
sir.
sir.
getting. That means what is dt here? Dt here is cosec square x minus cosec x cot x dx. Okay, so therefore, what does I become? Integral dt by t. Simply, we get log t and plus c. And what is t? Cosec x minus cot x. So now you understood why I put cosec x minus cot x is equal to t.
Yes, sir.
That is the reason. You have to remember the
Yes, sir.
derivation also. All these you have to remember the formula as well as derivation. Let us now come to the second one. That is second part. How to prove that it is equal to tan x by 2. Again, let us assume that I is equal to integral cosec x dx. Now cosec x can be written as 1 by sine x. So you can write this as dx by sine x. Okay. So now you can break by multiple angle formula. You can write sine x as 2 sine x by 2 cos x by 2. You can write, isn't it?
Yes, sir.
Now what you do here is
Yes, sir.
you try to bring a tan in the denominator. Okay, you try to bring a tan in the denominator. How will I bring tan in the denominator? How will I bring tan in the denominator? I will multiply. See, if I want to bring a tan in the denominator, what I have to do? I will have to write this as sine x by 2 by cos x by 2, right? If I want to bring a tan. But since this cos is
Yes,
extra, I have to multiply this by cos x by 2, right? And the one cos x by 2 already exists. I can write this way or not? Tell me.
yes, sir. Yes, sir. We can write
We
this
can write.
like
So
this.
now what does this become? This
Yes, sir.
becomes integral dx by 2 tan x, right? And cos square x by 2, right? Now
Yes, sir.
1 by 2 half you can take out of the integration because it is a constant dx. Now before writing dx, see that you have a cos square x by 2 in the denominator. Cos square x can be written as, in the, if I take it in the numerator, I can write this as sec square x by 2, right? And denominator I write this is x by 2, sorry. And denominator I write this as tan x by 2. Okay. Now see, what is the derivative of tan x by 2? It is sec square x by 2, right or wrong? So
Yes,
I'll
sir.
put t is equal to tan x by 2.
Sir, half into sec square x
Therefore,
by 2.
dt dx will become half sec square
Half into sec square x by
x by
2.
2. Okay.
Yes, sir.
So how much will be your sec square x by 2 dx? Sec square x by 2 dx will be half dt, right? Or 2
Yes,
dt.
sir.
2 dt it will be, not half dt.
Yes, sir. 2dt.
Be 2 dt. Okay. So now you put it here. Therefore, what does I become? I becomes um, half, we write as it is. And instead of sec square x by 2 dx, we write this as 2 dt. And tan x by 2, we write this as t. Okay. So now what happens? Half into 2, you take out this 2 cancels. You're only left with integral dt by t, which is what? Log t plus c. And what is t we had taken? T we had taken tan x by 2. Okay. Plus c. Clear? So both forms I have shown you.
Yes, sir.
Yes, sir.
Okay. Now sec square x by 2.
Yes, sir.
Yes, sir.
Next formula is sec square x by 2 can be done exactly similarly. I leave it to you as an exercise, but I'll show you two steps. The first formula for, I'll show you only the second part of this thing. First, the formula here is integral sec x dx is log sec x plus tan x dx. Sorry, not dx, plus c. Okay. And the second form here is log tan. Remember the formula, log tan pi by 4 plus x by 2 plus c. Okay, note, if instead of sec x, if you have sec ax plus b, then you can write this as log sec ax plus b plus tan ax plus b whole divided by the derivative of ax plus b, which is a. For the second part, if you write in terms of tan, it will be log tan pi by 4 plus ax plus b divided by 2 whole divided by derivative of ax plus b, which is a. This is the way you write. Okay. Moving on to the proof. First part, I'll just show you, for the first part, I'll just show you 2 lines and you will be able to do just as we had done cosec x. Okay, so you start by saying let I is equal to integral sec x dx, which you can also write as sec x by 1 dx. Now you multiply the numerator and denominator by sec x plus tan x. In the previous one, we are multiplying by cosec x minus cot x. This time we are multiplying by
Yes, sir.
sec x plus tan
Yes,
x.
sir.
And then you proceed exactly as we had proceeded earlier. You will show that you put t is equal to sec x plus tan x, and then you will show that numerator is the derivative of the denominator, so that this can be written as log sec x plus tan x. Understood? Plus c. Clear? Exactly. As we
Yes,
had
sir.
done cosec x. Let us
Yes,
now
sir.
see the second part.
Okay, sir.
Say let I
Okay,
is
sir.
equal to integral sec x dx. Now you know from negative and associated angle that integral sec x can also be written as cosec. This can be written as cosec pi by 2 plus x dx. We can write this way or not, because sec can be changed to cosec, right? So sec x can be written as
Yes, sir.
cosec pi by 2 plus x. And what is the formula for cosec? Formula for cosec was log tan, this formula, this one, log tan x by 2. Integral cosec x is log tan x by 2. So what you do here is log tan, what is x here? X here is pi by 2 oh, instead of this, um, yes, you can. Hmm. If you're writing this as pi by 2 plus x, this is pi by, what was the formula there? Log tan x by 2, right? What is x here?
Yes, sir.
Pi by 2
X by 2.
plus x divided by 2, right?
Yes, sir.
Yes, sir.
That was the formula for cosec. So now this becomes
Yes,
log
sir.
Yes,
tan.
sir.
If you separate now, this becomes pi by 4 plus x by 2. That's it. Plus c and a plus c here. Clear? So these
Yes,
formulas you
sir.
need to remember along with their proofs. Okay. So now let us try to do some problems based on these. Some of them definitely will be based on these, not all. Okay. So first problem here is or let me give you all together. Evaluate the following. Okay, number one, integral cot log x by x dx. Okay, this one. Next is integral sin x by sin x minus alpha dx. Next is all these are your IHC standard problems. Integral dx by root 1 plus sin x. Okay, and the next one is integral dx by root 1 minus e to the power of 2x. Okay, and the next one here is integral dx by 1 plus cot x. Okay, and you have sixth one as integral tan x tan 2x tan 3x. And sixth one integral tan cube x dx. Okay, these for the time being only these, and some more will follow after this. Okay, and after this I'll start integration by parts. Okay, so let us see for number one. Let I is equal to integral. The problem here is cot log x by x. Cot log x by x dx. You know that the derivative of log x is what? The derivative of log x is 1 by x, right? So what you do is you put t is equal to log x. Therefore, what do you get? Dt is equal to 1 by x dx, right? See, 1 by x, are you getting 1 by x dx here? This entire thing is equal to dt. So therefore,
Yes.
I becomes integral cot t dt. And what is the formula for cot x? It is log sin x. So this becomes log sin t plus c. And what is the value of t? Log x. So put it there. Log sin log x plus c. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
I'll finish, do one more, and then I'll continue in the next
Yes, sir.
class. Number two. Let I is equal to integral sin x by sin x minus alpha dx. Integration is very easy. If you remember the formulas, if you are good with differentiation, integration is very easy. You put x minus alpha is equal to t. So you get, what is the value of x here? X is equal to alpha plus t. Also, you have dx dt is equal to 1, right? That means dx is equal to dt, right? So therefore, what does this integral become? I is equal to integral sine alpha plus t. Remember, alpha is a constant. Divided by sine t dt. Now use compound angle formula. Sine alpha plus t is sine alpha cos t plus cos alpha sine t whole divided by sine t dt. Now you can separate. You can write this as sine alpha cos t by sine t dt plus integral cos alpha sine t by sine t dt. So here sine t and sine t they cancel, right? And what will happen to the first integral? You know that alpha is a constant, so sine alpha is also a constant. You can take it out of the integration. So sine alpha, and you're left with only cos t by sine t. Plus, you know that cos alpha is a constant, so cos alpha will also be a constant. Integral dt. So this becomes sine alpha, and cos t by sine t is cot t dt. Plus, and cos alpha integration dt is t. So this becomes simply t cos alpha. Okay, and integral cot t is what? Log sine t. So log sine t
Yes, sir.
plus t cos
Plus
alpha
t cos
plus a
alpha
constant of integration
plus.
sine alpha, and put
Yes,
the
sir.
back the value of t. What we had taken t we had taken to be x minus alpha. So put back the value. That's it. Okay, so I stop here for today.